Hello. Let's continue our class. For this example, we see that if you do not initialize the vector, then the vector size is 0. And then when you use pushback, then you increase the vector size. And this is very different from the static one. For this static array, the array size is always fixed. While if you use the vector, you can manually you can the vector size is automatically determined. And here is one pitfall for using the vector. So I saw some students write code like this, and these statements may lead to runtime errors. And can you know where the problem is? These statements can lead to runtime error. So can you know where the problem is? If you try to compile the code, you might not see the runtime error because sometimes the code is okay. But if you use different syntax, for example, you use @I, you call the @at function to replace the square bracket, then you can find the runtime error. Here we see that we see the runtime error. This program terminates due to the index out of range. If you use the brackets, you might not see this error message because in C++, C++ will check whether the index is inside the legal range. So if you use this style, you use brackets, then even if the index is outside the legal range, there is no warning. However, if you use vector and you choose to use the @, function, and if you use this function, then this function will check whether the index is within the legal range. So I recommend to use the @ function to replace the brackets, because the @ function can check the index. And for this example, we see that because we do not initialize vector 2, so its size is 0. So its size is 0. And if you want to access its element, for example, you want to access VC2 at the index 0, this creates this leads to index out of range because its size is 0. And we can correct this mistake. You can try to correct this mistake. For example, you can let VEC2 to have 5 elements, and each element is 0. Then you can fix this problem. You can initialize this array. But sometimes you do not want to specify the vector size. For example, sometimes you don't want to you do not know how large this vector is, so you want to so sometimes you do not want to initialize this array. Then you have the second option. You can use pushback. This function can automatically adjust the vector size. So if you use this function, you don't need to worry about vector size. So this function can automatically increase the array size. So if you do not want to initialize a vector, then you need to use pushback to insert elements to this vector. And we see that if you use this one, you use brackets, then you will find this program does not behave correctly, because this program do not output each element of this vector. So if you use this style, it is difficult to find where the problem is. So if you use the bracket, it is difficult to know where the problem is. But if you use the add function, this function can show you where the problem is. So if you declare a vector and you do not initialize this vector, then you cannot use brackets like this. So the correct way is to use the pushback member function to insert elements to this vector. And we also suggest to use the add member function to replace the bracket syntax. The next slide is about array initialization and the vector initialization. This is a comparison. Suppose we want to initialize all elements to zeros, and if you use static array, you can use this style or this one. But if you want to initialize to all ones, you want all the elements to be 1, then you need to use this or this one. But this one will this one is not semantically legal, because this one only initialize the first number to be 1, while the remaining elements will be 0. So this statement does not initialize all elements to 1. This is according to the C++ rule. If you specify array size and you only initialize some numbers, then the remaining numbers will be set to 0. So according to the C++ rule, this statement will create the remaining 4 elements will be set to 0. But if you use vector to do initialization, then you will not have this problem. For example, you want to initialize a vector with 5 zeros, or you want to initialize a vector with 5 ones. You can use these statements. Next, we will have a quiz. So, if you need answer sheets, please raise your hand. I need to close your laptop and close the tablet. Only after the quiz is over, you can start to use laptops or tablets. The first question is to determine the value stored at this pointer. 30 seconds left. Then I will turn on the second question. The second question is to determine the value of star PTR1 after the above statements. Uh, 30 seconds left. Then turn on the third question. The third question is to determine the value of PTR2 after the above statements. 30 seconds left. And I will turn off all the questions. If you use answer sheets, remember to write down your name and student ID. And please hand in your answer sheets. Let's see the answers to the quiz. For the first one, the answer is the option 3. We need to determine the value stored at this pointer. And a pointer is used to store memory address. So the value of this pointer is memory address. So the answer is either 2 or 3. And here we see this pointer is initialized to the memory address at index 0 of array, and plus 2. Plus 2 is pointer arithmetic. Here plus 2 means plus the memory size of 2 elements, and each element is 1 integer. So the size of each element is size of int. So plus 2 means plus 2 times size of int. So the value stored at this pointer is this memory address. And for the second question, we need to determine the value of star PTR1, and star PTR1 and the PTR1 is point to V1. So we need to trace the value of V1, and we see that V1 equals V1 plus star PTR2. So here we need to trace PTR2. PTR2 is point to V2, and the V2 is 7. So this value, V2 is 7. And then in this statement modifies V2. So V2 becomes 7 plus 5. So after this statement, V2 is 12. So here, star PTR2 is 12. And 12 plus V1 is 15. So the answer is 15. For this one, for the third question, we need to determine the value of PTR2. If you try to compile this program, if you try to compile, you will see syntax error because we see the syntax error is like this: invalid conversion from int to int star. On the right hand side, is star ptr1. Star ptr1 is to dereference a pointer. So on the right hand side is an integer, but on the left hand side is a pointer. PTR2 is a pointer. So PTR2 is int star. And because the data types do not match, so we cannot perform this assignment. So this statement leads to syntax error. Do you have any questions? If no questions, then we will return to the slides. Next, I will introduce vector assignment. So after we declare array like this, we can directly assign one vector to another vector. But for static array, you cannot use this. You cannot assign one static array to another static array. You need to use a for loop to manually copy each element. But for vector, you can directly use the assignment operator. So you can directly assign one vector to another. This can save you a lot of time. And you can also use the assign member function. To use this function, you need to specify two iterators. The iterators are to specify the range you want to assign. So for example, you want to assign the whole vector, the whole my vector. Then you provide two iterators. Where begin this member function will return one iterator pointing to the beginning of this vector. And the end member function will return an iterator pointing to the element after the last element. It is better to refer to the figure. So we can refer to this figure. Suppose this vector has 5 elements. And then if you call the beginning member function, this function will return an iterator pointing to the first element. And if you call the end member function, this function will return an iterator pointing to the element at the index 6. At the index 5. Here is at index 5. And the rule, the principle is that end minus begin will equal to size. So the principle is to so if you verify that end points to 5 and the begin points to 0. So 5 minus 0 is 5. And the size also equals 5. And you can do some practice to learn how to use the assignment member function. For example, suppose I want the first 3 elements. Then you can use suppose I want to assign the first 3 elements of my vector to his vector. Or you need to declare and then call assign. If you so here we see that we assign the first we assign the first 3 elements of my vector to his vector. So here you need to specify 2 iterators. The two iterators specify the range you want to assign. Now suppose if you want the last 2 elements, you can use end. Now suppose you want the last 2 elements, you can use end. Then here you use end minus 2. So if you want the last 2 elements, you can specify the 2 iterators like this. You can also use begin, but begin requires you type more words. And here is another way to assign a vector. For example, you want to specify you want to assign 5 ones to this vector. You can use this function call. So we see that after this assignment, the elements of his vectors are 5 ones. So if you want 100 ones, you can change 5 from 5 to 100. So we see that the vector size is automatically adjusted. So the array size is dynamic for a vector. And we don't need to worry about memory allocation because the implementation of the vector library already do the task for memory allocation and for memory allocation. Here are some functions to access elements of a vector. So we already know we can use the at member function to replace the bracket operator. We can also use the front member function to obtain the first element of a vector, or we can use the back function to obtain the last element of a vector. So you can so you can do some experiments. So this is the same as you use index, you access element at the index 0. We can use back to obtain the last element, and here you can use my vector size. So you can use back to obtain the last element, or you can use the index, but this requires you to write more characters. Next, I will introduce how to iterate over a vector. Suppose we have a vector, and the method one is to use index to access vector elements. So we already know how to use this method. This is the ordinary method, and I always recommend you use this style, because this style is readable, is the most readable one. And we can also use iterator. Iterator is like a pointer, so you can use the begin member function to return an iterator, and you dereference this iterator to obtain the value of this element. So you can so we see that to obtain the first element, you can also use iterator. So I use begin to obtain the iterator pointing to the first element. Then I use star to dereference. So I obtain this value. And so we see that the three values are the same. And if you want to obtain the value at index 1, then you perform iterator you perform iterator addition. This is like a pointer addition. So this means you add the memory size of one element. Then you perform the reference again. So this you will obtain my vector at index 1. So the iterator is like a pointer. So if you know how to use pointer, then you can use you know how to use iterator. The method 2 is a bit more advanced, so I will skip this one. If you are interested, you can look at the textbook, or you can search. You can search the keywords to know how to use method 2. I always recommend method 1 because this one is is easy to use and easy to read. And next, I will introduce some member functions in the vector library. And these functions are pushback, popback, clear, erase, insert. And we already use the pushback function. This function is to add one element to the end of a vector. And the popback member function is to delete the last element from a vector. And the clear is to make the vector empty. The erase member function is to erase one or multiple elements from a vector. Insert is to insert one or multiple elements into a vector. Here is one example. Suppose we declare my vector like this. And if we push back 1 and push back 2, then this means we add 2 elements to the end of this vector. So after the 2 statements, the vector contents becomes this one, and we see that 1 and 2 are added to the end of this vector. And next, if we perform popback, and then this will remove the last element from this vector. So after this statement, the last element is removed. So the vector contents becomes this line. And then if we perform erase, we need to supply 2 iterators to specify the range we want to erase. Now suppose we want to erase the first 2 elements. So now suppose we want to erase 5 and 6. We want to erase the first 2 elements. Then we need to specify iterators like this. The first iterator points to the first element. The second iterator points to the element at index 2. So after this erase statement, we have 7, 8, 9, 1. And next, we perform insert. Suppose we want to insert one element 10 in the beginning of this vector. Then we can use the insert function. And then we need to supply the iterator to point to the position we want to insert. And because we want to insert element to the beginning of this vector. So here we use the begin member function. And the second input is the value we want to insert. We want to insert 10. So after this statement, we insert 10 to the beginning of this vector. And we can also insert multiple elements. To insert multiple elements, we can use this statement. So suppose we want to insert 3 negative ones. So then first you specify the iterator where you want to insert the position you want to insert, and then you insert. Then you input the number of elements, and the third input is the value you want to insert. So after this insert, we have the vector contents like this. I think the time is up, so we can take a break for 10 minutes.